Hey there, welcome to dotnetFlix. Hey Sander,
Hi Edwin.
I guess you want to talk about event sourcing, right?
I do
Yes.
want to talk about event sourcing.
Anything particular implementation?
So we are going to look at implementation on top of CosmosDB.
Wow.
And we actually already talked about event sourcing way back in the day, in
Yeah.
2015.
Yes,
I
our
guess
first
it was.
year as dotnetFlix.
It was the first year. It was one of the first episodes, still in Dutch though.
Yeah.
And we talked about event sourcing implementation on top of Azure Storage.
Okay.
Yeah, and I wanted to take another look at that code and modernize that a little bit, use CosmosDB now that we've got all the goodness that
Yes.
is CosmosDB. But before we dive into that, I want to tell you about a project I've worked on a couple of years ago now to just get a general gist of what is event sourcing, why would you want to do that, and then we'll dive into an actual implementation on top of CosmosDB.
Okay, so this runs in production somewhere.
Yeah, it runs in production, but on Azure Storage.
Okay.
So the CosmosDB implementation is just a hobby project. I wanted to see if I could make it work on top of CosmosDB as well.
Okay, show me the money.
Okay, so the slide I've got here is for this, legacy electricity meter. It's a real mechanical meter.
Mm-hmm.
And I don't know, do you have one of these? Or
No,
do you have
I
the,
just
the
got
new
upgraded.
fancy? Okay.
Yeah.
So
This is for electricity and gas, but you're looking at electricity today.
Yeah, so
Basically.
basically. So these meters, they've still got a lot of these in the Netherlands, but we are all being upgraded to these new fancy smart meters, right? And there are some benefits because with the old meters, you had to do the meter reading yourself. And then you had to go to the website of the supplier and enter the meter reading. With these new smart meters, the electricity companies can take those readings automatically by themselves.
Yep.
Right? And this also opens up some new business opportunities. So this project I worked on, let's just call it Energy Insights for now. It was basically an app and a whole platform to help users get insight into their energy usage. And then we would do that by taking the meter readings, visualizing them in some various ways, and then also apply a little bit of gamification to that. So we, for example, had benchmarks comparing your energy usage to some similar households in your neighborhood, and you could check if you were doing better or worse than you were doing your neighbors, stuff like that. So this is my electricity usage from, I guess it was November of last year. So I'm doing pretty well here because the orange line, that's the line for the similar households, and I'm pretty nice below that. I also do have some solar roofs on my or solar panels on my roof, so that probably helped a lot.
Yeah, probably.
But as you can see with this data, there are obviously also some privacy considerations here, right? So how do we actually get this data from your meter? So let's start at the beginning. I've got my home is situated somewhere. I've got an electricity meter installed there. That meter is identified by some ID, that nice long EON number you see there. And the only company that is allowed to take those readings by law is the grid operator. Mm-hmm. And they can only use that data 6 times a year for invoicing purposes only. And that's the only thing they can do with it. However, if a customer explicitly gives permission to us to do something else with that data, we are allowed to. But we need to have the explicit permission. And we are also being audited on that. So once a year, an auditing company will check if we've got the right permissions and if we're not doing anything funky with
So that's a
with
very
data.
important part of this application to collect these mandates from the customer that you can use this data.
Exactly. And the way we do that is we let a customer register a meter. Yeah. We know from metadata where meters are installed, the home addresses. So we send a activation letter to the home address, which acts as a randomly generated activation code. And then once the user has received that letter, he or she can go back to the website and activate a meter. And then we're at least pretty sure that it's his or her meter, right? Yeah. And so with that data, with that list of mandated or activated meters, we can go to the grid operator and show them that list of permissions. Yeah. And then when they've accepted the list, we can get the meter readings. Right?
Yep, makes sense.
So now we've got all this data, we've got meter readings, and we've got that very important list of mandates. So how do we store that? Well, if we took a more traditional approach, we could simply store all that in like a meter table and have a row for each meter, right? And we can identify it by that unique number that you saw for the meter. We can track the status, whether or not it has only been registered or whether it has been activated. And we can add some other columns with information. But there are some drawbacks to this approach because we don't have any historical information here. We don't know why this meter is activated, if that's even the right status for this one. And we cannot gain any new insights from the history. So this is where event sourcing comes in. So instead of just storing a current snapshot of the state, we are storing the state as a complete sequence of events of everything that happened. So as soon as a meter is registered, we store that as a distinct event in the store. Yeah. Then when the meter is activated, we store that as a separate event. And now we've got all this nice history, and if we want to know the current state, we simply take all those events, play them back, and now we know what's the current state.
You have to play them back in the order that they occurred.
Yeah.
And this is like a concept, right? This is not CosmosDB or storage. This is just the concept that you implement on top of a storage mechanism.
Exactly. So this is the design pattern, and as we'll see later, it's pretty easy to actually implement on all kinds of storage mechanisms.
Cool.
And so you store those in what you would call an event store. Now it's also pretty important with event sourcing, especially if you look at our scenario, because one of the benefits we get out of this is that 100% accurate audit logging. Yeah. So there's no chance of our primary database being out of sync with some secondary audit log, because our primary database is our audit log. Yeah. But for that to be true, you also need to make sure that it's immutable. Mm-hmm. So just like an accountant, I cannot simply take an erasure and modify historic data, right? Yeah. The events that happened. This also allows for pretty cool temporal or point-in-time queries. Mm-hmm. Because if I want to know what the current state is, I don't have to replay the complete stream. I can replay up to a month ago. And then I know whether or not the meter was activated at that point in time. So the guys who actually did the audit on the system were pretty impressed with this because we could answer a lot of, we could give them very detailed answers to their questions. Yeah.
And you could also see whether or not a mandate was revoked and then registered again and stuff like that. That's all in the information of the events.
Exactly. Yeah. And that's also interesting to detect if something funky is going on.
Exactly.
Right?
Yeah.
If you get a lot of granted, revoked, granted, revoked, granted, revoked, something weird is happening.
Yeah.
So let's build an event store.
Let's do that.
Building an event store is, by the way, a really fun and some way to really get to know these patterns. And to start with one is really not that difficult. So basically this entire interface is what I need to set up a simple event store. Yeah. I need some kind of way to load a stream based on some stream ID, and I would get back this event stream class. Now this event stream class is just a simple container. It contains a list of events, ordered according to how they are ordered in the event store. Then I need some way to add events to a stream. So that's where the append to stream async method comes in. It takes a stream ID, it takes an expected version. The expected version is used for optimistic concurrency.
Makes sense.
So if two clients are trying to update the same stream, they both will load the stream, make the updates, try to write them back. They both give their respective expected versions, and one will win and the other will get an optimistic concurrency exception. And then, of course, you need to pass the list of events you want to update.
So you could call this the repository for your event store. This is what your application uses to store and retrieve data about an entity that is identified by this ID.
Exactly. And if you want to add a domain layer on top of this, then you could create a repository class which would use this iEvent store interface to actually do the persistence and the loading.
Cool.
Also notice that I don't have a delete or update or stuff like that. It's just immutable appending only.
Yeah. So also pretty fast.
Yeah.
I have no locks and stuff like that. I can just append to the stream and that's it.
Yeah.
Cool.
So we're going to implement this on top of Azure CosmosDB.
Oh
so
yeah, going global.
yeah, well, we're not going global yet, but we can pretty easily.
Yeah.
So CosmosDB is this multi-region, multi-model global distributed database. And we will use just the native SQL API for this.
Yeah.
That's the same API as they had when this was still called DocumentDB.
Okay. But you could have used some other API or some other model, right?
Yeah, you can implement it on top of MongoDB, you
Yeah.
can implement it on top of table, all kinds of stuff.
Cool.
Yeah. So let me switch to the to some code here. There it is. Well, actually, let me first go over to the Azure portal. There you can see that I've created a CosmosDB instance, event sourcing demo, and there are 3 containers below that. I've got an events container, so this will be the container that will hold all my events. And I will simply store each event in its own document or item in that container. And then I've got these other 2, these we can ignore for now, they will become important later when we're trying to query stuff.
Okay.
Just want to show you that the events, if we go to the items, this is still empty, so nothing fancy going on behind the scenes here.
Nothing in your sleeves.
No shenanigans.
No shenanigans.
Okay, now I've created some test code. So let's just start a debugger and go through some of this code. So first of all, I've got this class here, CosmosDB Event Store, which is just my implementation of that interface I showed you.
Okay. Yeah.
And I need to give it some stuff to be able to connect to the database. So I need an endpoint URI, I need the authorization key, and I need the name of the database.
Makes sense.
Standard stuff. And then I need some kind of event that we want to store in there, right?
And
So-
I guess it's just a plain old C# object. It's just
Yeah, so this
ETL.
is just a POCO. We can small look. I'm inheriting here from event base.
Okay.
Event base is also nothing fancy going on. That's just an I event which has timestamp, so I don't need to set a timestamp on each of my objects.
It's a convenience-based class.
And that I event, it just declares the timestamp. That's it.
Yep.
So I'm creating this new meter register because when a new consumer comes to the site, this is the first thing they need to do, register the event. And it has a meter ID, it has the home address, and it has some kind of super secret activation code, right? This is really random. And then let's just, because one is just boring, let's create a different event, a meter activated event. This is interesting because the interesting fact is that a meter has been activated at a certain moment in time. We don't need any more information for that. So this event doesn't have any properties.
It's only the timestamp.
It's only the
Data type,
timestamp, and it's
yeah.
only because the event name is already very expressive in what happened. You don't need any more information.
Yeah, and I think that's important, right? You have to really think about what is the intent of this event, what happened, and you need to be able to know what this means, this event.
Exactly. You
interpret
really
it.
need to think hard about the naming, and they need to express the correct intent. So they need to be really aligned with your domain model or your domain language.
Cool.
Okay, so now we want to append these 2 events to a stream, right? Because in this demo, I'm using a single stream for each physical meter.
Yeah. So the meter could be your entity, so to speak, and every entity has an event stream in the database, right?
Yeah,
Okay.
exactly. And that's a nice match because generally you would want your entity or aggregate to be your transaction boundary.
Exactly.
And a stream is also a transaction boundary.
Yeah.
So let's give that stream a name. So I'm using a pattern here where I use the type of the entity in the name of the stream ID, and then I'm postfixing that with the actual ID of the meter.
Makes sense.
And then I can simply call that append to stream, async method. I'm giving it a stream ID. I'm giving it an expected version of 0, which basically means I expect that there isn't a version of that stream in the database
You're
right
starting
now.
a stream for this entity.
Exactly.
Yeah.
Then I'm giving it an array of events, and then I'm checking that my result is true, and then that test has completed. So if we now go back to the portal and I'm refreshing this, you can now see that we've got 2 documents in there. So the first document is our meter registered event, and our second document is our meter activated event.
Nice.
Now if we look at this document and let's see what's in there. So we've got this payload element which contains simply the serialized version of my event object, right? So this is the actual data in the event. But I've also added some metadata onto it. So I've added this event type field, which contains the name of the event, which is pretty important if you ever want to deserialize that payload back into an object, right? Yeah,
and this is JSON, so I could basically ingest this stream in any platform or any language that I like if I can parse JSON.
Yeah.
And then if I look at the event type, I know what this means, what that type is. Okay, cool. So no type information or type information in there.
I explicitly did not use the CLR type just to be more independent.
Yeah, cool.
And then I've also got some metadata about the stream. So I know that this document belongs to the stream meter1, and we are now at version 1. So each time I add a single event to the stream, I'm incrementing the version number by 1.
Okay.
So if you look at meter activated, that actually has just that really lightweight payload with only the timestamp, and now we're in the same stream, but we are at version 2.
Okay, and just to be sure, if I understand correctly, you have within this stream object, you have an ID. That is my unique ID of the entity.
Yep.
And the ID that's on top, that is the ID of this, let's call it a record, or this document.
Absolutely. Yeah.
Because, and in there is the ID and also the version number.
Yeah.
Did you do that with a certain purpose, or is it just to make it unique or something like that?
So the important thing is that this thing will be unique.
Okay, so this is the primary
CosmosDB.
key. Let's bring it back to the SQL.
Right. It's to make each document unique.
Okay.
I could have used just a simple GUID for this. Yeah, because I'm not using it for anything else. But because in the Data Explorer, you see the IDs on the left side. I want to use something very visually.
Yeah, and this could also be, because if this is the primary key and there maybe could be a unique constraint on it, then you also guard against inserting two records with the same version for the same ID. Yeah, I don't know if you use it here, but that's
good. Well, I'm not using it explicitly because the only thing I'm doing is I'm adding new events to the database. And if that ID already exists, then CosmosDB will give me an error.
Awesome. Cool.
So let's look at some code so you see how this works, right? So if we go back to that, let's see, where is it? Append to stream async method, that must be where all the magic happens. So let's dive into that.
And the magic happens asynchronously?
It always happens asynchronously.
Wow.
Otherwise it's not good magic. So there's not a lot of code here, and that's because all the code is basically hidden away in a stored procedure. So why is that? Because I need to do some stuff in a transaction. I need to first check the version number, and then I need to add, probably multiple documents, one for each event. And CosmosDB certainly supports transactions, but only server side. So you can start transaction triggers in stored procedures, but you cannot start a transaction directly from your client's C# code.
Makes sense.
So what I'm doing here is just calling this sp append to stream stored procedure. Now that stored procedure must take some input, right? The expected version and the events. So I must have some way to get my events up to that stored procedure. So the way I do that is I simply serialize all the events to JSON and then pass that JSON document to the stored procedure.
Makes sense.
So if you look at the stored procedure right now, we've got those same arguments coming in, the stream ID, expected version, and events, which is now a JSON document. The first thing I do is I select the maximum version for that stream ID. Right, so if I would do this now on the current state of the database, I would get back 2. Right? And then, I execute the query, I check that I've got some sensible result, and then I take the current version from that result. And now I can do my optimistic concurrency checks. So either I'm asking for expected version 0, and in that case there shouldn't be a current version, I shouldn't have gotten a result back. Or I do have a result, and in that case it should match the expected version that I gave to the stored procedure. So if one of those two cases is true, then everything is fine. We can continue with transaction. And I basically take the JSON document I've got, I parse it back into event objects, and then for each event I create a document.
Cool.
And then I'm returning to signal to the client code that everything worked fine, and otherwise I'm returning false and everything worked not so fine. So that's really not much code.
This is in JavaScript because you write.
This is JavaScript because you write server-side stuff in JavaScript in
for CosmosDB. Yeah, okay. But in SQL Server, you could have done this also with a store procedure if you wanted to do it completely server-side. So that's a choice, technology choice.
Exactly. So if I would build this on SQL Server, I would have, exactly, like you said, I would have a choice. I could do it in a SQL store procedure. I could also do it from client code.
But this is an important part to look at, specifically if you design this. This transaction is really important because if that goes wrong, then you could have multiple events with the same version and you get issues. So you need to make sure that this works and test it thoroughly.
All this append to stream needs to happen completely
must be
atomically or not at all.
Yeah, makes sense.
So let's go back to our demo scenario and go to the next one, because this is pretty low level, right? We're directly interacting with the event store. But we've already mentioned the word entity a couple of times. Normally you would want some additional domain layer with your entities and your business logic, nicely encapsulated in some
because
entities.
Also events need to be created somewhere. There need to happen something that will result in an event.
So an event is a result of some business logic executing, right? So where do I put this business logic now? Okay, so let's just start the debugger again and walk through another test. So I'm starting first with a new meter. So my meter ID is now 2. It's also a different address. So this is actually the address for a conference center where DevSum was in Stockholm, where I gave talk about this subject. Still got that same activation code.
I expected super secret 2 now.
Yeah, that probably would have been better, but
I'm not the PO, so this could be a problem.
Probably. Okay, so now instead of just creating events and appending them to the event store, I'm creating this meter object. And I'm giving it the initial data, all the minimum data I need to create a meter object. And if we jump in that object, we see that it has a couple of properties. So those properties are just to keep the current state. And then the constructor we are calling is this one. And this is where things are starting to get interesting, because as you can see, I'm not directly assigning these incoming values to those properties. Because if I did, we wouldn't be doing event sourcing, right?
And they're also immutable, right? You cannot set them from outside the entity.
I cannot set them from outside the entity.
That's a design constraint.
Yeah,
cool.
Definitely. So instead, I am creating this event, encapsulating this occurrence of creating a new meter inside this event. And then I'm passing that event to this apply method, and the apply method does two things. So first of all, it will add this new event to a list of pending changes. Because at some point in time I need to save this back to the database. Otherwise it isn't persisted. And once I've done that, it's time to mutate the state of this object. So I'm calling this mutate method.
This will actually change the properties of this entity.
And the way I do that is I'm using some C# shenanigans with dynamic, so I'm casting everything to a dynamic, and then I can let the C# compiler figure out which overload to call, because I've got these different overloads for all my different types of events. So if I jump in there with F11, I'm getting in the correct overload, the meter registered, and only now am I setting all the properties and fields. And using this pattern, you can replay an object back from its events loaded from the event store. And
this is basically the create me a meter event and set this state. That is the first one.
Exactly.
Yeah, cool.
So now I've got this meter instance, and if we look at it in the debugger and the inspector, you can see that it's representing the current state. It's still not activated, but it has a meter ID, it has a postal code, stuff like that. And it does have that single change.
And this is all in memory. I haven't done
It's all in memory, so it's not persisted yet, it's still not in CosmosDB.
You're still in your business logic stage.
Yeah, right.
Cool.
So, well, let's go up to that point and see how we can persist it. So I've created this meter repository class, which is just a simple wrap around my event store.
Yep.
So if I jump in there, you can see I'm giving it a new event store and I'm saving that. And then
It's dependency injection doing its work.
yeah, well, some manual dependency injection.
Yeah,
here.
but it's DI nonetheless.
It is. That's true. So and then I can call this save meter async method, and I'm giving it a meter.
Yep.
So the first check I do is, do I even have any change? Because if I don't have any changes, I can just return true. There's nothing to save. If I do, let's figure out the stream to update. Again, I'm using the same pattern here, just the name of the entity plus the ID of the entity. And then I call our good old method append to stream, and I'm done. Just you can notice here that I'm not only saving an array of changes in the event, I'm also saving the version of the event, because I still need that for optimistic concurrency.
Yep, makes sense.
So this should be true. So if we quickly go back to the data explorer and I refresh that, you can see that I've got now a single event for meter 2. Here's my meter registered with correct address.
Cool.
Okay, so let's execute some actual business logic. Let's add some business logic to this object, because right now it's just it doesn't add anything,
No.
right?
So the user wants to activate
Yeah.
their meter and calls some backend service that
Exactly.
does this. Okay.
And let's say this is a week in the future, because we need to send that letter by snail mail, and
Yep.
it will be slow, stuff like that. So we don't have this object in memory anymore.
No.
So we need to load it from the repository. So I'm just calling this repository load meter async method.
Using the ID, which makes sense.
Using the ID, so based on the ID I can know what my stream ID is. Then I can call the load stream method, which will give me back my stream, which is just a containing class containing the events, with only a single one, the ND version, right?
Yep.
And now I'm using a different overload of the constructor of meter. I'm using the overload which simply takes the list of events. So skip over that one. Okay, so here we are at that constructor. And now what I'm doing to reinstate this object, I'm just iterating over the events, and for each event I'm calling the mutate method.
Yeah.
And that mutate method will set the properties.
Yeah.
So after all of this is said and done, I've now got my meter object back into memory. You can see it still has the right postal code, still not activated at this point, and I don't have any changes yet, because I've just loaded it from the
It's fresh
from the
from the
repository.
database.
It's fresh.
And I think it is very important to stress that in those mutate functions within the domain object, you don't do any side effects. You don't go around calling services or stuff like that, because you only want to change your internal state and that's it. You change properties and that's it.
Yeah.
Because a question that we get a lot for this type of event store is that people say, well, if I have 100 events and I all have to replay them, that's going to be really slow. But you know, 100 events just setting some properties is pretty fast.
That is pretty fast.
Yeah.
And otherwise, if you're really getting into a lot of events, there are some paths to deal with that. You can take some snapshots. You can add some caching. Caching is really easy with event sourcing because it's immutable, so you don't have caching validation. So there are ways to work around it.
Yeah, but that's important design decision that you need to take. Don't do any side effects in your mutate function.
Definitely.
Okay, cool.
So let's look at our actual business logic. So I've encapsulated that in this activate method, and I'm giving it our super secret activation code. So in this method, I can first of all, I can do some checks based on the current state of this object, because it's replayed, right? So it's in the current state. So maybe if I'm already activated, I want to throw an invalid operation exception.
So here
that
you
could
do
be part of a business logic.
Yeah. So this is business logic, business rules, and checking your invariants. You do that the first thing when you call this method.
Yeah. And then I'm checking to see, okay, so you want to activate your activation code correct. Well, because the object was replayed, I've got the activation code in this underscore activation code field, and I simply compare those two.
And in this phase, I could do some external stuff, right? So now
Yeah,
I could call a service or stuff like that.
Yeah, I could call an activation code service to check there or some stuff like that. The important thing is that the outcome of this business logic is captured in an event.
Exactly. Or some events. It could be multiple, right?
It could be multiple, definitely.
Cool.
So in this case, it's just a single one. It's if everything's correct, it's the meter activated event.
Yeah.
And again, I'm giving that to the apply method, which adds it to the pending list of changes, and it will call the mutate method. Now what's also very nice here is that if this fails, I think that's a pretty important event as well.
Yes.
So I've captured that in a meter activation failed event.
Nice.
And that way you can also do later on some reporting on your event store from, how many times does it happen that somebody types in the wrong activation code? Maybe we can do something about it.
Cool.
So that's everything that's important or maybe important to you in the future to capture, put it in an event, right? So let's jump out of there.
And that's awesome for auditors because they can look at this log and they see exactly what goes on with
Exactly.
Nice.
Yes. And we've had some complicated cases where people started using the platform, then stopped for a while, and then started again, like New Year's resolution, right? Let's start again with this whole energy usage stuff. But in that meantime, where they weren't registered, we didn't have any rights to their data, and we had to show that to the auditors. So this, I'm saving it back now. This should have worked. So yeah, this test passes, so let's go back. Refresh, and now we should see that the meter has been activated, right? So it's been activated.
Yes.
Okay.
If you grasp the concepts of event sourcing, then this is pretty simple code, right? It does complicated stuff. You have an audit log and all that stuff for free, but the code is pretty simple.
Yeah. Cool. It's not much code, especially if you're building on top of something like CosmosDB or SQL Server with support for transactions. You don't need a really big framework to make this work.
No.
But you're right, you really need to have a good grip on the concepts. Talking about concepts and patterns, we've got another pattern which is very important for this, because now we want to do some queries.
Yes, I was thinking already how you're going to do that on your event stream.
Yeah, so...
Basically you don't.
Well, in a way, for a single event stream, it's not that important, right? So, or not that complex, because as we just seen, I can simply load a stream, replay it, and I can ask it questions. Are you activated? What's your postcode address? So for a single event stream, just load the event stream and you've got your answer. But things will get more complicated if you want to do some multi-stream queries. So let's say I've got thousands, or in our case, tens of thousands of meters of streams in my platform. And I want to know how many activated meters do I have?
At a certain point in time.
At a certain point in time. So the naive way would be to, we will load all the streams.
In memory.
We can rehydrate them to an object, replay them, and then we can ask each object, are you activated? Are you activated? Are you activated? And simply count those instances where they return true.
This is possible.
This is certainly possible. And if this is the only thing your system needs to do, then it
might be viable.
Maybe it even works, right? But this is not really scalable. If I've got a lot of these types of queries, this is not really manageable or scalable at all.
Let alone if you do reporting with all kinds of dimensions and aggregations. This is not going to work. So
this is not going to
scale at least.
So we need something else, and that something else is command query responsibility segregation, or CQRS. And again, the essence of the pattern is really simple. It basically states that where at first you had this one thing, this one data model, our event store data model, now separate those out into two different models. Where we've got a write model for our events or our commands, and a read model for our queries. So in our case, the write model would be where our event store would live, and the read model would be something else. So if we look at a scenario we just walked through, let's say an activate meter request comes in, that will go to the write model. There all our domain logic is being executed, and that raises some event. That event goes to the event store, like a meter activated. And now we've got these new type of classes called projections, which take those events and can update the read model. And the read model can be anything you like. So it can be a bunch of materialized views in blob storage. It could also be like a SQL database with a couple of tables, which are much easier to query than an event store table.
So instead of having one normalized model for writes and reads, and for the read side I could have multiple queries with joins and stuff like that.
Yeah.
I could now create multiple projections that create a view specifically for the purpose I want to need that view.
Exactly.
Wow.
Exactly. And
That's
because
cool.
you separate those concerns out, you can optimize each model for its use case.
Nice.
And then the clients can simply go to the read model for the queries.
And that could even be a different database. It could be SQL Server or Mongo, whatever. It could
Yeah.
be different.
So in real polyglot scenarios, you could even have different read models, like a SQL database for some of the read models, or blob storage for other read models.
Yep, cool.
So now one thing that's very, very, very important is that this is somewhat transactionally, because if I'm appending a new event to the event store, I need to be damn sure that all projections get that event, because otherwise I will become out of sync and my views will be utterly useless, right? So ideally this would be a transaction, but that's not always possible given the various...
you could build this in one process and make it sort of transactional, but
yeah,
this will probably be distributed because you want to scale it out
exactly.
In different ways.
Luckily for us, CosmosDB has this awesome feature called the change feed.
Wow.
And the change feed is basically just a large queue inside of CosmosDB containing all your changes from the beginning of time. And you can replay that list.
Cool.
And then they've also added this NuGet package for the change feed processor. And that NuGet package, that library, makes it very easy for you to create an instance of an AI observer interface. And that instance will get called each time there is something new in the database.
Okay. So it's not a polling model, but you get
The polling is basically done for you
on the
by the library.
Okay.
Yeah. So that's very nice. And now I can create all kinds of projections on top of that, right?
Cool.
So let's just look at some projections classes I've created here. So I've got two examples. I've got a let me see. Yeah, let's start with this one. So this is basically an implementation of the problem I suggested a couple of slides ago, where you would want to know the total number of activated meters, right?
Yep.
So this would be my view. Just a number.
Yeah. It's the sum of all the activated meters
Exactly.
at a certain point in time.
And for now, I'm storing the views also in CosmosDB, because why not? It's a NoSQL database. I can really easily store JSON documents here. So it's a good place to store the views as well. Yeah. But I will store it in a separate container, in that views container we saw. And I've created this projection class. And this projection class needs to derive from a projection base class I've created. And I'm giving it a type of view that it needs to deserialize from and serialize to.
Yeah.
So we don't have time to get into all the details of that projection base class. All the code is up on GitHub, so you can also look at it later. But basically what that does is it makes sure that all the events that it gets from the change feed are being applied to this projection code here.
Cool.
So for each time an event is raised from CosmosDB.
Which means it is stored in the event store.
It's stored in the event store and made available through the change feed. Here in the constructor, I can register which ones I'm interested in.
Cool.
So I say, hey, whenever a meter activated happens, please call this method. Whenever a meter deregistered happens, please call this method. Yep. And here I've got my handlers. And it's really simple. Each time it's activated, I'm incrementing by 1. And then when it's deregistered, it's no longer on the platform. I should decrement by 1.
Yeah, and although this looks very trivial, like you're just increasing and decreasing a counter, but you now have implemented it using a pattern that makes it scalable. It is running separately from the right side. You can scale that differently. So you're basically cloud native now. You can just scale this up into the cloud.
Yeah. This scales very
You can
nicely.
do millions of event streams and then have multiple instances of this one.
Yeah, right.
Cool.
So my other projection is a little bit more complicated because now I want to know for each meter, I want to know what my daily totals are, but grouped by week. Okay. So for each meter, for each week, I get a single view. And that view contains basically 7 numbers, the daily totals for that week.
Makes sense.
But now if I'm creating multiple views, I need some way to give those views a name, right? And that's where this overloaded get view name method comes in. I'm getting past the stream ID and the specific event, which is being triggered on, and I can use data from those parameters to determine the name of my view.
Okay.
So I'm getting the meter ID from the stream ID, I'm getting the week number from the event,
Yep.
which is crazy more difficult to do in C# than you would expect when you're working with week numbers.
Yeah, dates is always hard.
Yeah, so thanks Stack Overflow. And then using that data, I can create my name for my view.
Makes sense.
And then again, I've just got this really simple handler here. When readings collected, event comes in. I'm just summing that for a whole day, and I'm adding that to the consumption.
Yep. Cool.
Okay, so let's see this actually working. So we've only got 2 streams with 2 events each, and there aren't any meter readings collected events in there. So I'm just running this test to append some more events to the streams. So after this has run,
So this is
This
just to make
will-
the demo more interesting.
yeah,
Yeah, people at home, this is to make the demo more interesting.
So-
We care,
we care.
totally.
So you can see I've got now some more
yeah.
more interesting stuff, and if I pick one randomly, you see it's a meter readings collected and it has some randomly generated meter
okay.
readings in there. So it's like 96 readings, 50-minute interval readings for a single day.
Yep.
So and now I can start my projection engine. So the projection engine, all it does is it starts listening to the change feed, and when something new comes up, it gives that to the projection classes.
Cool.
Now I'm putting that in debug mode so I can continue working. And now we should start seeing views to show up. Let's give it a couple of seconds. Yeah, here we go.
Nice.
And there are some more. I think those are all. Yeah. Okay, so let's start with our total activated meters view. So for the first projection, I didn't explicitly set a name, and then it simply takes the class name of the view.
Okay.
So it's called total activated meters. If I go there, I see that we've got 2 activated meters, which is correct. You can also see that I've added some information about checkpoints. So the reason I did that is because maybe in the future, or maybe due to some kind of error or failure situations, I need to replay some events back from the change feed.
Yeah.
And if I replay this entire feed, I don't want this count to become 4.
No.
Because there are still 2 activated meters.
Okay.
So I need some kind of way to know up to
Where
what
was I?
point
Yeah, exactly.
did I process the events. Right?
Yeah. And that's based on the timestamp then.
That's based on the timestamp.
Event timestamp.
Right.
Yeah.
Only that timestamp is only, well, it's actually the timestamp of the, it's the CosmosDB item timestamp.
Okay.
So
Yeah.
it's assigned by the
Yeah,
CosmosDB.
but it's not, I mean to say, it's not the timestamp at the last time the projection ran.
No.
But it is actually the last event timestamp
Yeah.
that you processed.
Exactly.
Okay.
But that's only precise up to the second.
Mhm.
And as you've seen, we're doing a lot of stuff inside transactions. So if I'm pending 10 events in a single transaction,
Yeah.
those all fall in the same second. They've got the exact same timestamp. So that's not enough. So I'm also keeping a list of all the events I've processed within that second.
Okay.
So usually this list only contains a single event, but if a lot of events occur in the same second, this event can become larger, or this list can become larger. And because I'm saving it in this same document, so I'm saving my result, count as 2, along with where was I in the stream,
Yeah.
I can be sure that it's totally idempotent.
Yeah.
I'm not.
And you're
processing.
updating this record
Yeah.
time after time. It's
Yeah.
not that you have multiple totals, but just one record that you update, and then
Exactly.
to this checkpoint you know where you were in the
Exactly.
stream. Cool.
Now for the other projection, you can see that we've actually got now three views
Yep.
for 3 weeks per stream. So if I look at, let's say this one, meter number 1 for
Yep.
week 24, I can see that I've got this nice payload with a consumption.
Ah, cool.
And in the actual project we generate a lot of these type of views. We actually store them in blob storage. we actually store them zipped.
Ah.
So they are very small. It's very fast to transfer them to the client browser.
Yeah.
And we create these views for day, week, month, year, and you get great performance. You do get a lot of views, but storage is really cheap, so that's not really an issue.
And these views, like I said, they're already optimized for the view that you want to present to the user. So it's no joins and stuff. You just get the data and basically data bind it to the presentation technology.
Exactly. The only thing the API does is when it gets a question is figure out, what's the name of this view, and it takes it from blob storage, returns to the client.
Cool. Pretty high performant, I guess.
Yeah. So that's basically CQRS. Let's look at some takeaways and wrap this up. So one thing that's pretty important is that these patterns are not really top-level architectures. No. If you're creating this entire microservices system, you're not obligated to apply this everywhere. You usually apply this inside a single service where it makes sense, right? Yeah. And they can be used together very well, but you don't have to combine them. If you don't have multiple stream queries, you don't have to use CQRS. And more importantly, the other way around, if you want to use CQRS, you definitely do not have to use event sourcing if it's not a good match for your project. Another thing we already briefly mentioned, I think, is that eventual consistency is not a given per se. So the way I've set this up with the change feed, I'm eventually consistent because there's a little bit of time between writing the event to the event store and having my projections being updated. Yeah. If that's not possible for your project, for your scenario, if you really need that immediate consistency, you can create that by, for example, putting everything in SQL Server, both your events and your views, and updating that in a single transaction. Yeah. That won't scale as well as an eventual consistent solution, but maybe you don't need that skill. So do what's right for your scenario.
So it's the whole CAP theorem thing, like do you need consistency or do you need availability?
Yeah,
you have to choose between them.
Yeah.
Yeah, cool.
And then starting out with these kind of new patterns and new implementations of these patterns, I would always start small because there are some frameworks out there. But as it turns out, you don't really need a framework for doing the basic stuff. So just start small, create some base classes, make your own. Yeah. Then you really learn it by heart, and then you can start looking at maybe some products.
Yeah, and then you're also better at evaluating whether or not you need the framework. Most of the time they're opinionated, and if it's your opinion, then it's okay, but you don't want to be forced in a certain way of working. And if you grasp the concepts really good, then you're able to make the distinction.
And understand the fundamentals first. And then maybe you're getting into a situation where you want all kinds of advanced cool stuff. Then there probably comes a time when where it's not smart anymore to start building all that stuff yourself, but then you can look at stuff like Event Store, which by Craig Young, which is a very nice event store. But don't start there. Don't start with the giant elephant. Just start small.
Yeah. And make sure that you know what you need.
Yeah.
Cool stuff.
Yeah, so that's basically everything I want to show you.
Pretty cool.
Today.
Yeah, thanks so much. I think this is a real good overview of the concepts and how you could implement this. And like we said, it's not just only for CosmosDB. You can do it on SQL Server. You can do it basically also testing. You could also do it in memory or whatever.
Definitely.
So it's all about the concepts. I hope you guys liked it and learned something about these kinds of patterns. Maybe you can use them in production. So have fun with that. Thanks for watching and see you next time, the next episode. Bye-bye.
Bye.